Hello and welcome all. In this presentation, I am going to discuss about linked list data structure. Today I am going to cover the following topics: advantages and disadvantages of array, what is linked list representation, advantages of linked list, and recap of the session. Before knowing what is linked list data structure, we must know the advantages and disadvantages of an array. First, we'll start with the advantages of an array. Here, the elements are faster to access by using the index value, index number. So, this index number indicates the location of the element in the array. For example, this element 10 resides in location 0. So, this 0 is the index value for 10. So we can access the array elements with the help of index value. It is an easier task. And next is searching an element is easier here. The same with the help of this index value, and array stores the elements in contiguous memory location, that is in sequential manner, one after another. Searching process is also very much easier here. And next is array stores elements in a sequential manner in memory location, that is in contiguous memory locations. For example, your 10 is residing in 1000 memory location. I'm talking about the computer memory location, not the index value. If your 10 resides in 1000, and since this is an integer array, each element takes 4 bytes. Okay, next your 25 element will be at 1004 location, and next will be at 1008, and next will be at 1012 and 1016. Okay, so like that, at contiguous memory locations the array elements gets stored. So this is also a beneficial one for searching and accessing the elements from the array. So these are all the advantages of array. Next is disadvantages of arrays. Arrays got some disadvantages, some drawbacks, like array size is fixed, which means when you declare the array sizes, for example, in a program, when you declare array size as 10, throughout the program the array size will be 10 only. If you want to increase the array size by 15 or 25 or 50, it is not possible with arrays. The one thing you can do is you have to create a new array and you have to copy down all the old array content to the new array. So that is a time consuming one. Okay. So once the size is fixed, once if you have declared the array size, then that is a fixed one. You cannot increase the array size. And next is insertion and deletion operation in array are time consuming. Even though your searching operation will be an easier one in arrays, your insertion and deletion process is tedious one here. Why? Because if I want to insert, for instance, to insert any element in this array, let's consider in between this 25 and 30, if you want to insert 30, then you have to right shift the elements. Okay, you have to move this 42 to the next position, 40 to the next position, 30 to the next position, and so at the place of 30 you have to insert that like 35 or 45, some new elements. Okay, so likewise for deletion operation also you have to shift left. Okay, if you want to delete this 40, you can do it by shifting the next element to the prior position. So likewise, for insertion and deletion, some shifting operations are required. So it is also a time consuming process. Next is memory is allocated at compile time. So when you allocate memory at compile time, then that is called static memory allocation. Okay. So what is this compile time memory allocation? So which means before the program execution, the memory will be allocated. Okay, so that is called compile time memory allocation. Since the array size is fixed, before the execution of the program, the memory will be allocated for the particular array. So that is called compile time memory allocation, or we say static memory allocation. So the static memory allocation is a very important term regarding your arrays. Okay. So before the program execution, the memory will be allocated. So that is called static memory allocation. Next is why linked list. Our array has got some disadvantages. Yes. Like the array size is fixed and it follows static memory allocation, which means you cannot change the size of an array during the execution. Okay, so during the declaration of the array, if you give the size as 10 and you cannot able to increase the size later. So that is the main disadvantage of array data structure. To overcome that disadvantage, we are using this linked list data structure. Okay, so this linked list data structure follows dynamic memory allocation. Okay, it allocates the memory dynamically. So it follows dynamic memory allocation. So which means during the execution of the program, the memory will be allocated, not priorly. Okay, during the execution of the program, the memory will be allocated for the data. And you need not define its size at the time of declaration. So as with the array, you need to declare the size priorly, right? Well, declaration itself you have to, you need to declare the size as 15, 20, something like that. But in linked list, you need not do that. So this is the advantage of linked list. It follows dynamic memory allocation and you need not bother about the size of the list. And next is, what is linked list? So a linked list is a linear data structure. It comes under linear data structure like your array. Array is also a linear data structure and linked list is also a linear data structure that stores a collection of data elements called nodes. So we are going to store the data elements in nodes that are randomly stored in memory. Okay, so in your arrays we store contiguously, but here random memory. So here it is stored randomly in the memory. Okay, it is a linear data structure that stores a collection of data elements called nodes that are randomly stored in the memory. And here the nodes are connected by pointers. Okay, so each data item is stored with the help of nodes, right? We call each data element as node here. Okay, so that nodes are connected, linked with the help of pointers. And next is memory is allocated at runtime, which means dynamic memory allocation. So during the program execution only, the required memory will be allocated for the data item. Next we'll see the linked list representation. So this is the representation of linked list. Okay. So it has two fields. A node has two fields. One is data field and another one is next field. Okay. So this data field contains the actual data. Okay. What you are going to store in memory. So that will be stored in your data field. Okay. And the next part is next field. So this next field contains the address of the next data item. Okay. So your node contains two fields. One is data and another one is next field. Your data part contains the actual data, what you are going to store, is stored in your data field. And another is next field contains the address of the next data item. Okay. Next we'll see an example for it, linked list representation. You know, a node contains two things. One is data field and another one is next field. Data contains the exact actual data and the next field contains the address of the next pointer. Okay. Let's see an example for it. Your first node, the first node we call it as the head node here. Okay, head. So like this only your linked list will be data next, and the second element will be stored in the node 2 and also data next part, and for the third node also data and next part will be there. Last node next point and next field will be always null. Okay, so this represents your end of the linked list. This null pointer represents the end of the linked list. Usually it is the last node of the linked list. In this presentation we have discussed about the advantages and disadvantages of an array, why we need linked list data structure, what is linked list, and linked list representation. That's all with this presentation. Thank you.